Hello dear students, welcome to the lecture 5 of Software Engineering course. Today's topic is system modeling and part 1. Let's start. The topics covered today are
Context models, interaction models, structural models, behavioral models, model-driven engineering.
System modeling.
System modeling is the process of developing abstract models of a system, with each model presenting a different view or perspective of that system. System modeling has now come to mean representing a system using some kind of graphical notation, which is now almost always based on notations in the Unified Modeling Language (UML). System modeling helps the analyst to understand the functionality of the system, and models are used to communicate with customers. Existing and planned system models. Models of the existing system are used during requirements engineering. They help clarify what the existing system does and can be used as a basis for discussing its strengths and weaknesses. These then lead to requirements for the new system. Models of the new system are used during requirements engineering to help explain the proposed requirements to other system stakeholders. Engineers use these models to discuss design proposals and to document the system for implementation. In a model-driven engineering process, it is possible to generate a complete or partial system implementation from the system model.
System perspectives.
An external perspective, where you model the context or environment of the system. An interaction perspective, where you model the interactions between a system and its environment, or between the components of a system. A structural perspective, where you model the organization of a system or the structure of the data that is processed by the system. A behavioral perspective, where you model the dynamic behavior of the system and how it responds to events.
There are 4 system perspectives, which are external perspective, an interaction perspective, a structural perspective, and a behavioral perspective. This is important UML diagram types.
Activity diagrams, which show the activities involved in a process or in data processing. Use case diagrams, which show the interactions between a system and its environment. Sequence diagrams, which show interactions between actors and the system and between system components. Class diagrams, which show the object classes in the system and the associations between these classes. State diagrams, which show how the system reacts to internal and external events.
There are 5 different types of UML diagrams, which are activity diagrams, use case diagrams, SECourses diagrams, class diagrams, and state diagrams. We will see each of them.
Use of graphical models. As a means of facilitating discussion about an existing or proposed system. Incomplete and incorrect models are okay, as their role is to support discussion. As a way of documenting an existing system. Models should be an accurate representation of the system but need not be complete. As a detailed system description that can be used to generate a system implementation. Models have to be both correct and complete.
Context models.
Context models are used to illustrate the operational context of a system. They show what lies outside the system boundaries. social and organizational concerns may affect the decision on where to position system boundaries. Architectural models show the system and its relationship with other systems.
Okay, system boundaries.
System boundaries are established to define what is inside and what is outside the system. They show other systems that are used or depend on the system being developed. The position of the system boundary has a profound effect on the system requirements. Defining a system boundary is a political judgment. There may be pressures to develop system boundaries that decrease the influence or workload of different parts of an organization.
Okay, so the context of the MHC PMS. What was this? This medical healthcare. I couldn't remember. Let me check it. Okay, mental health care patient management system, which we have seen the previous lecture. So this is the context diagram. Let's check it by one. So there is system, patient record system. These are system components. Management reporting system, HC statistics system, which is a healthcare system. It is MHC PMS as a core system, appointment system, admission system, and prescription system. So this is the context. Okay, you see it is composed by many of the subsystems, and when each of them gets together, it composes the mental health care patient management system. Okay.
Process perspective. Context models simply show the other systems in the environment, not how the system being developed is used in that environment. Process models reveal how the system being developed is used in broader business processes. UML activity diagrams may be used to define business process models.
In this semester, I am going to give you a project as a final exam, as a semester exam, and in that project you are going to use UML diagrams. So try to give more attention to diagrams. Okay.
Process model of involuntary detention.
Okay, so this is the process model of involuntary detention. What does involuntary detention means? It means that they are going to put you into detention center without your, let's say, request. Okay. So it starts with confirm detention decision. Okay, so the process is starting with confirming that the detention decision is valid or not. Okay. Then inform patient of rights. It means that after the detention decision is confirmed and it is authenticity is verified, the patient is informed about her rights. Okay. Then record detention decision, as can be seen here. It means that the detention decision is recorded to the logs. Okay, log system, which is going to do our mental health care patient management system. Then at the next stage, it is decided that the patient is either dangerous or not dangerous. If the patient is dangerous, find a secure place. Process is started. You see there is a decision here, decision dialog. Then if a secure place is found, is available, it is going to do transfer to secure hospital. Okay, this process is started. If there is no secure hospital, Then the patient is transferred to the police station. If patient is not dangerous, it is directly sent to the hospital and it is recorded to the admission system, or let's say we can say that the admission system is deciding to send him to the hospital, to which hospital. Okay. After these three processes, they are all going to use these processes: inform social care, inform next of kin. Next of kin means that inform a relative of patient. Update registers. The update registers is about the system itself, again the main system. Then the process model of involuntary detention is completed. Okay. So this is a UML diagram of process model of involuntary detention. You will be needed to draw these kind of UML diagrams in your project for the semester project of this course. Okay.
Interaction models. Modeling user interaction is important as it helps to identify user requirements. Modeling system-to-system interaction highlights the communication problems that may arise. Modeling component interaction helps us understand if a proposed system structure is likely to deliver the required system performance and dependability. Use case diagrams and sequence diagrams may be used for interaction modeling. Use case modeling. Use cases were developed originally to support requirements elicitation and now incorporated into the UML. Each use case represents a discrete task that involves external interaction with a system. Actors in a use case may be people or other systems. Represented diagrammatically to provide an overview of the use case and in a more detailed textual form.
Okay, so we are going to now see the transfer data use case. A use case in the mental health care patient management system. So the medical receptionist transfer data to patient record system. Okay. And this is the use case UML diagram. And here the tabular description of the transfer data use case.
MHCPMS, transfer data.
So the actors, who are the actors here in this case?
Medical receptionist, patient records system, PRS.
So the description of actors.
A receptionist may transfer data from the MHCPMS to a general patient record database that is maintained by a health authority. The information transferred may either be updated personal information, address, phone number, etc., or a summary of the patient's diagnosis and treatment.
Okay, so this is a tabular description of above UML diagram. Okay. So the data, what is the data that is transferred?
Patient's personal information, treatment summary.
What is the stimulus of this action?
User command issued by medical receptionist.
What is the response of this action?
Confirmation that PRS has been updated.
Okay, so what could be the PRS? I think it is personal record system. Let's check it. Okay. Okay, there is personal response system. Okay, anyway, it could be any of them. And then continue. So what are the commands?
The receptionist must have appropriate security permissions to access the patient information and the PRS.
Oh, the PRS is the patient record system in this case. Okay. Okay, so
Use cases in the MHCPMS involving the role medical receptionist.
the use cases of medical receptionist can be listed as this in a UML diagram. The medical receptionist can register patient, unregister patient, view patient info, transfer data, and contact patient. So you see, each of these are an action. So this is the use cases of actions of medical receptionists. Okay. And then sequence diagrams.
Sequence diagrams. Sequence diagrams are part of the UML and are used to model the interactions between the actors and the objects within a system. A sequence diagram shows the sequence of interactions that take place during a particular use case or use case instance. The objects and actors involved are listed along the top of the diagram, with a dotted line drawn vertically from these. Interactions between objects are indicated by annotated arrows.
So this is the sequence diagram for view patient information. View patient information is an action. Okay, you can see here. So this is the sequence diagram for it. Okay, so let's see it. So the medical receptionist can use view info command, and view info command is taking patient ID, as you can see, as a parameter. For this command to work, there is authorization at the below, and authorization, if authorization fails, there is error, no access message, and the authorization is okay, there will be patient info returning. So from the PID, the patient info is looked for, then a report is generated from where medical healthcare patient management system database, as you can see. And when this system is tried to be accessed, it authorizes info and the user ID, which is the medical receptionist info and user ID. If authorization is successful, the database returns patient info. So I will try to oh, there is a sequence diagram for viewing patient information. Transfer data. Okay, so there is another sequence diagram which is for transfer data. This was for the view patient information, and there is also data transferring of this. Okay, before moving to that, I will try to explain this diagram with the order of events. So, when medical receptionist request patient information, okay, it's the program sends the patient ID that the medical receptionist is trying to find, the ID of that person, patient. Then patient info service tries to generate report, okay, from database, and to access the database, it requires authorization. From what? From the medical receptionist information and the user ID. Then if authorization is successful, the patient information is returned, okay, from here, and the data is returned to the medical receptionist. And if there is no access, okay, no data is returned. Therefore, actually, we can say that when the information is requested, first the structure of information is verified, and then if it is verified, the authorization is checked, and if everything is successful, the patient information is returned, and if authorization fails, error, no access. Okay, so this is the order of the events. And then there is transfer data diagram. So this was the view patient info diagram, and now we are going to see the sequence diagram of transfer data. For transfer data, first of all, the medical receptionist login into the patient record system, as you can see. Okay. So after login message is successfully returned and the authorization is successful, the process starts as below. So it's the medical receptionist sent info, and with update info command, as can be see here, then it sends another command, update patient record system with user ID, then checks the authorization with TF and UID. Then the authorization is successful. The update patient ID update command is sent with patient ID. If update is okay, a message of okay is returned, and after the message okay is returned, then there is update summary command is sent, and it sends summarize user ID command, again checks authorization. If authorization is successful, summary is generated, and update command is sent again, and the update is okay, the message is okay, and then the logout command is sent. Okay, so this is the sequence diagram for the transfer data. These diagrams are depending on your planning and let's say development. Okay, your system doesn't have to be like this, of course. The stages may change. However, for this system, the software engineers prepared the sequence diagram like this. So their system will work with this order. Okay. The authorization is made here. Why do you think that? Actually, the medical receptionist has already logged in. The authorization here probably used to authorize that whether the medical receptionist has authority to update, let's say, patient record system. Okay, that it could be that perhaps the administration has blocked that particular medical receptionist to update patient data. So the authorization is made here. Okay. And there is another authorization here. That authorization is here as well. So these authorizations are not just simply login, they are about authorizing that particular action can be done by that particular user, in this case medical receptionist. Okay.
Structural models. Structural models of software display the organization of a system in terms of the components that make up that system and their relationships. Structural models may be static models, which show the structure of the system design, or dynamic models, which show the organization of the system when it is executing. You create structural models of a system when you are discussing and designing the system architecture. Class diagrams. Class diagrams are used when developing an object-oriented system model to show the classes in a system and the associations between these classes. An object class can be thought of as a general definition of one kind of system object. An association is a link between classes that indicates that there is some relationship between these classes. When you are developing models during the early stages of the software engineering process, objects represent something in the real world, such as a patient, a prescription, doctor, etc.
Okay.
UML classes and association.
So one patient is associated with a one patient record. Okay. So this is a one by one association. One patient cannot have multiple patient records. Okay. This is like when you are building a user, let's say you are building a student management system and you have students table and you are assigning each student a student ID, then you can't assign multiple student IDs to a single student. Okay, this is like that. A single patient gets a single patient record, a single patient ID. Classes and associations in the mental health care patient management system. So one consultant can be assigned to multiple patients. As you can see, one consultant. I'm going to copy this to explain better. Okay, let's use the paint of the Windows. Okay. So, so the one consultant, let's make the color, can be assigned to multiple patients, right? Because each consultant can be consulting multiple patients at different times. Multiple conditions can be assigned to multiple patients. One patient can have 3 conditions and another patient can have 5 conditions and such. Okay, multiple patients can be assigned to one general practitioner. Okay, so they are basically giving each patient to a single consultant or single general practitioner. They are not assigning a single patient to multiple consultants or multiple general practitioner. It could be done in other systems, but in this system, they say that you get one consultant and you get one general practitioner. Okay. However, a single general practitioner can, of course, be assigned to multiple patients. Then one patient can, multiple patients can attend the consultation multiple times. Okay. And moreover, one to up to 4 hospital doctors can give multiple consultation. Okay. So 4 doctor up to maximum that patients can consultation. A patient can get consultation from 1 to 1, 2, 3, 4 of doctors. Then multiple consultation can prescribe multiple medications. So each patient can get prescribed at each consultation multiple medication, and each patient can get multiple prescription or can get multiple treatment at each consultation. So this is the classes and associations in the medical mental health care patient management system. You see the numbers are defined like this, and it is the way it works. Okay, so this is their system design. It could be different in your design as well. Okay, this is their system modeling. The consultation classes are like this. So in a consultation class, there are these variables which are doctors. Each doctor can be also another object, another class. Date, time, clinic, reason, medication prescribed, treatment prescribed, voice notes, transcript. And this consultation class has the following methods, which are new, new consultation, compose a new consultation, prescribe a medication or treatment, record notes, you see there are notes, and transcribe and more. So this is the class of consultation. You see the inline objects and methods are differently displayed. So the key points of part 1.
A model is an abstract view of a system that ignores system details. Complementary system models can be developed to show the system's context, interactions, structure, and behavior. Context models show how a system that is being modeled is positioned in an environment with other systems and processes. Use case diagrams and sequence diagrams are used to describe the interactions between users and systems in the system being designed. Use cases describe interactions between a system and external actors. Sequence diagrams add more information to these by showing interactions between system objects.
So there is two type of diagram. Use case describe interactions, and sequence diagrams add more information to these interactions. Okay, like here, let's recap it. So you see this is a use case. It is pretty simple and doesn't contain much information. However, when we check the tabular description and the sequence diagram, we can get much more information. Okay.
Structural models show the organization and architecture of a system. Class diagrams are used to define the static structure of classes in a system and their associations.
So these are part of structural model. Okay. And this is the classes and associations. Okay, so we are going to start part 2. I'm going to take a break. Okay, so part 2, generalization.
Generalization. Generalization is an everyday technique that we use to manage complexity. Rather than learn the detailed characteristics of every entity that we experience, we place these entities in more general classes: animals, cars, houses, etc., and learn the characteristics of these classes. This allows us to infer that different members of these classes have some common characteristics, e.g., squirrels and rats are rodents. In modeling systems, it is often useful to examine the classes in a system to see if there is scope for generalization. If changes are proposed, then you do not have to look at all classes in the system to see if they are affected by the change. In object-oriented languages, such as Java, generalization is implemented using the class inheritance mechanisms built into the language.
This is also valid for C# as well, and perhaps some more other programming languages.
In a generalization, the attributes and operations associated with higher-level classes are also associated with the lower-level classes.
I am showing examples of this in object-oriented programming course. You can watch that course's videos as well.
The lower-level classes or subclasses inherit the attributes and operations from their superclasses. These lower-level classes then add more specific attributes and operations.
Yeah, exactly like this. So let's take a look at the generalization hierarchy.
A generalization hierarchy.
So at the top of the hierarchy, there is doctor. So this is the most general object class, let's say. From this class, there are two subclasses, children classes. A doctor can be hospital doctor or general practitioner. Then hospital doctor can gets two subclasses. First, consultant and a team doctor. So the consultant is the child class of hospital doctor, and team doctor is child class of hospital doctor. However, then team doctor is parent class of trainee doctor and qualified doctor. So each one is either child or parent of another class in this diagram, and this is how they are let's say positioned. So then from team doctor class, a trainee doctor and a qualified doctor class is generated. Each class contains the attributes and methods of parent class, unless that method or attribute is private. Okay, there are accessibility modifiers which are public, private, protected, and internal. I show all of them in object-oriented course, so you can watch our object-oriented course videos as well. Let me show it on our channel. Our channel name is
Herkese merhabalar arkadaşlar. Bilgisayar becerileri
Software Engineering Courses, and when you click our channel URL, you will see our playlist and you can watch this
and it will install like this.
playlist. I suggest you to watch also. You see, currently we are at the lecture 5, like this lesson, this course. Okay, so let's continue.
A generalization hierarchy with added detail.
So when we add the detail, you see the main class, the most general class, doctor, has name, phone number, and email. Then it has two methods, register and deregister. Then from doctor class, when we compose our subclasses, child classes as hospital doctor and general practitioner, the hospital doctor gets two new attributes, staff and pager. General practitioner get practice and address. Okay. All right. So hospital doctor having the features here, and also having these two features, and general practitioner having the features here, and then these two new features.
Object class aggregation models. An aggregation model shows how classes that are collections are composed of other classes. Aggregation models are similar to the part of relationship in semantic data models. The aggregation association.
So patient record is aggregated from patient and consultation like this. So this is the aggregation association. Let's see if there is a better example on the internet. Okay, UML composition versus aggregation.
UML composition versus aggregation versus association.
So you see there is association, aggregation, and composition. Let's check the explanation.
What makes a UML composition different from an aggregation or a regular association? The concepts of association, aggregation and composition exist in UML since the first published versions, but the exact meaning of these concepts, especially the aggregation, still leads to heated debates among UML experts. But before we go into the details, let's have a look at how these concepts are defined in UML. I guess every UML user is familiar with the graphical notation, but how do these concepts look like in the UML v2.5 meta model?
So the UML is a standard that is being developed, and it has, of course, versions. When we check the index, let's see the final UML. Okay, I'm trying to find. You see, there are so many information related to UML. Okay. Okay, it is down from object management group, and let's see the final version. Okay, structure diagrams, component diagrams, class diagrams, use case diagrams, activity diagram. Okay. Sequence diagram, communication diagram. You see there are so many diagrams. So this is a class diagram. You see owner string balance $0 and such. There is file activity and use case. Okay. Check email. This is sequence diagram, as you can see, and this is communication diagram. Okay, let's continue from this page. Okay. Okay, currently it seems like the aggregation is still not standardized. Okay, there is some more information here.
The main difference between aggregation and association is that aggregation is a type of association, which describes the has a relationship between two objects, while the association is a relationship between two objects.
Okay, so this makes sense. It means that it has a. So patient has a record. However, patient record doesn't have a patient. Okay. So from this meaning, I think we can get some more information. I will try to show. Okay, so house has a window. However, window doesn't have a house or something like that. House has a side window. House has a back window. House has front window. Okay. Okay, that example was not correct. Oh, you see, UML version 2.5 has 752 pages. This is really big stuff. Definition functionality. Okay. Okay, let's see. What is aggregation?
What is aggregation? Aggregation is a type of association. In other words, it is a special case of association. When an object has another object, we can consider it as an aggregation. Thus, aggregation explains the has a relationship between objects. In UML, a diamond symbol represents an aggregation. The direction describes which object contains the other object.
Okay, so this describes the object contains the other object. In this case, okay, so whichever has the diamond means that it contains the other object, I think. Yes, person has head, person has hand, and person has leg. Okay, therefore, patient record has patient. Okay. So a patient may not have a patient record. However, each patient record has a patient, and each patient record has a consultation. However, each consultation doesn't have to have a patient record. Okay, so this makes sense. So this is the aggregation association. And there is also association. Association means that there is a relationship between objects.
What is association? Association is a relationship between two objects. It can define the multiplicity between objects. It denotes whether the objects have one-to-one, one-to-many, or many-to-many associations. For example, assume that there are two classes, A and B. If one object of A relates to one object of B, then it is one-to-one association. But, if one object of A relates to multiple objects of B, then that relationship is one-to-many. Similarly, if multiple objects of A are related to multiple objects of B, then the relationship is many-to-many. Therefore, these relationships define the association between objects.
Okay, so I think it is more clear now. So this is a one-to-one association of also, and this is one-to-many association, like we have shown here. So this is the many-to-many association. This is one-to-many association. These are the associations, and this is the aggregation. Okay, so let's continue with behavioral models.
Behavioral models are models of the dynamic behavior of a system as it is executing. They show what happens or what is supposed to happen when a system responds to a stimulus from its environment. You can think of these stimuli as being of two types. Some data arrives that has to be processed by the system. Some event happens that triggers system processing. Events may have associated data, although this is not always the case.
So when some data arrives, it has to be processed by the system. Therefore, data arrival stimulate a method, for example, that will process the data. And there is events. When an event occurs, it may trigger some other events, and events may also have associated data. Also, although this is not always the case. Okay.
Data-driven modeling.
Okay.
Many business systems are data processing systems that are primarily driven by data. They are controlled by the data input to the system, with relatively little external event processing. Data-driven models show the sequence of actions involved in processing input data and generating an associated output. They are particularly useful during the analysis of requirements as they can be used to show end-to-end processing in a system.
Okay, so
An activity model of the insulin pump's operation.
this is the activity model. There is blood sugar sensor, and it gets sensor value from the sensor, then it gets sensor data, then from sensor data compute sugar level. From sugar level, the blood sugar level is computed. So you see they have different type of geometric drawings to let's say define each action and value. So this is an action, get sensor value, and this is data. Okay, so this is action and this is generated data or output maybe, and this is action, you see, and this is the data. Okay, so this is how they are put inside squares or these shapes. So this is the activity model. It is pretty simple. It gets the blood sugar sensor, then get the sensor value, then get the sensor data, then compute sugar level, then get the blood sugar level. Probably blood sugar level is from memory, and by computed sugar level, it calculates the insulin delivery, then it calculates the insulin requirement, calculate the pump commands, then get the pump control commands, then call that commands to the control pump, then control pump insulin goes to the insulin pump to pump insulin into the blood sugar. So order processing, this is another model of processing orders. When a client orders a purchase, it goes to purchase officer. The purchase officer fills the order, and a validate method is called and validates the order is filled correctly or not. If validation is okay, then the budget is checked, and then data store orders are saved, and then the order is sent to the supplier. Okay, so this is the order processing.
Event-driven modeling.
So these are, I think, data-driven modeling. These two are, you see, they are based on data, and there is also data.
Real-time systems are often event-driven, with minimal data processing. For example, a landline phone switching system responds to events such as receiver off hook by generating a dial tone. Event-driven modeling shows how a system responds to external and internal events. It is based on the assumption that a system has a finite number of states and that events, stimuli, may cause a transition from one state to another.
Okay, this is important. It has an assumption that system has a finite number of states.
State machine models. These model the behavior of the system in response to external and internal events. They show the system's responses to stimuli, so are often used for modeling real-time systems. State machine models show system states as nodes and events as arcs between these nodes. When an event occurs, the system moves from one state to another. State charts are an integral part of the UML and are used to represent state machine models.
Okay, so this is the state diagram of a microwave oven. You see it switches between states, and in the beginning state it is waiting to display time. If you go and check your microwave oven right now, you will see that it is just displaying time and waiting. Okay, so this is a state diagram of a regular microwave oven, and in the waiting period it can be either full power or half power. If it is full power, it set the power to 600, and then when you set the timer, it set the timer, and from full power it can go to half power based on the action, or from half power it can go to full power. This is changes according to our setting. Okay, you see when we are setting timer of microwave oven, we can set it to either full power or half power. This is about that. You see there is timer command which is coming from the user. Then when we set the timer, it sets the timer from the number we have input, and then it checks whether the door of the microwave oven is closed or open. If it is open, it will be in disabled mode and it will display waiting for door to be closed. When door gets closed, or at the beginning if the door was closed, it will get into enabled state and it will display ready. Then we will be able to hit the start button. When we hit the start button, it will start operating the oven. If meanwhile the operation is continuing, door get opened, it will get into the disabled state again, and it will be do operation unless we cancel the operation or the operation ends. Let's say after we cancel the operation or the operation ends, it will get into the waiting to display time state again. You see it is the beginning state of here. Actually this is a loop like this. So this is a state diagram of a microwave oven. There are finite number of states, you see, and based on the user action, user input, it works. It is not a data driven, as you can see.
States and stimuli for the microwave oven.
So this is the tabular description. The state waiting.
The oven is waiting for input. The display shows the current time.
So the half power state.
The oven power is set to 300 watts. The display shows half power.
The full power state.
The oven power is set to 600 watts. The display shows full power.
So set time state.
The cooking time is set to the user's input value. The display shows the cooking time selected and is updated as the time is set.
You can try to remember how your microwave oven works, and it is usually like this.
Oven operation is disabled for safety. Interior oven light is on. Display shows not ready.
This is the disabled state, and let's go to the enabled state.
Oven operation is enabled. Interior oven light is off. Display shows ready to cook.
And there is operation state.
Oven in operation. Interior oven light is on. Display shows the timer countdown. On completion of cooking, the buzzer is sounded for 5 seconds. Oven light is on. Display shows cooking complete while buzzer is sounding.
Okay. So this was the states and their description. Then states and stimuli for the microwave oven. This can be also called as the events caused by the user, or methods called by the user. Half power.
The user has pressed the half power button.
Full power.
The user has pressed the full power button.
Timer.
The user has pressed one of the timer buttons.
Number.
The user has pressed a numeric key.
Door open.
The oven door switch is not closed.
Door closed.
The oven door switch is closed.
Start.
The user has pressed the start button.
Cancel.
The user has pressed the cancel button.
So there is also the modeling of microwave oven operation. Operation state is the state where the microwave is running. So it has checking, do check status, turntable fault, emitter fault. If there is a fault, in the checking state, it checks whether the system is running correctly or not, there is error or not. If there are faults, if there are errors, it display the event, what is the event? The event of the failure, and then alarm sound is sounding. Then it gets into the disabled state. You see, after if the checking fails, it gets into the disabled state, which was the state here. Okay. If the checking is okay, when this checking happens after we hit the start button, and then it starts do run generator cook, and after the timeout happens, done, buzzer on, 5 seconds, or if we hit the cancel button, it gets into the waiting state again. Okay, or if you open the door, it gets into disabled state again. So this is the operation UML diagram.
Model-driven engineering. Model-driven engineering (MDE) is an approach to software development where models rather than programs are the principal outputs of the development process. The programs that execute on a hardware-software platform are then generated automatically from the models. Proponents of MDE argue that this raises the level of abstraction in software engineering so that engineers no longer have to be concerned with programming language details or the specifics of execution platforms.
Okay, this is more like a this is more like a science fiction at the moment. It is quite not easy to achieve this kind of modeling and then generating their software. So it is really hard to achieve. Okay.
Usage of model-driven engineering. Model-driven engineering is still at an early stage of development, and it is unclear whether or not it will have a significant effect on software engineering practice.
Okay, so the pros of model-driven engineering
allows systems to be considered at higher levels of abstraction. Generating code automatically means that it is cheaper to adapt systems to new platforms.
Okay, so the cons of model-driven engineering.
Models for abstraction and not necessarily right for implementation. Savings from generating code may be outweighed by the costs of developing translators for new platforms.
Okay.
Model-driven architecture. Model-driven architecture (MDA) was the precursor of more general model-driven engineering. MDA is a model-focused approach to software design and implementation that uses a subset of UML models to describe a system. Models at different levels of abstraction are created. From a high-level, platform-independent model, it is possible, in principle, to generate a working program without manual intervention.
So it is possible in principle, however, in actual life, there is still no such system. or a general system, let's say.
Types of model. A computation-independent model, CIM. These model the important domain abstractions used in a system. SIMs are sometimes called domain models. A platform-independent model, PIM. These model the operation of the system without reference to its implementation. The PIM is usually described using UML models that show the static system structure and how it responds to external and internal events. Platform-specific models, PSM. These are transformations of the platform-independent model with a separate PSM for each application platform. In principle, there may be layers of PSM, with each layer adding some platform-specific detail.
So, model-driven architecture transformations are like this. There is computation-independent model. There is domain-specific guidelines. They get into translator, and translator also takes user input. Then platform-independent model is generated. From platform-independent model, there are two outputs to platform-specific model and translator. Also, translator gets platform-specific patterns and rules. Then translator also generate output for platform-specific model. After platform-specific model gets input from platform-independent model and translator, it goes into translator again, and this time translator gets language-specific patterns. Then platform-specific model outputs another output for executable code. So the final executable code is generated from both translator and platform-specific model. However, this is in principle, there is, as far as I know, there is no such system, at least a general system for like this. And there can be
Multiple platform-specific models.
There can be .NET Translator. It generates platform-independent model. Then it goes into the Java Translator and Java-specific model and Java code generator and Java program. Then it can get to the .NET specific model, C# code generator and C# program. This is can be called as porting. Porting is rather a different thing. It is possible. However, it is not like you generate abstract model and generate the code automatically. It is like you are coding in a upper level, and then that code turns into the specific platform coding. Uh, okay, you can find some information. Okay, I think I will find a better example like Xbox, PlayStation, PC. Okay.
What you will get from this page: tips for setting up your development environment to make games for PlayStation, Microsoft Xbox One, and Nintendo Switch.
Okay, this was not a good example. Uh, okay, I'm trying to find a good example of. Okay, you see there are several general purpose cross-platform app development platforms. Probably they are using this or okay, so there are the stages of mobile application development: planning, analysis, design, development, testing, release, support. How to create a development brief. Okay, there are native or cross-platform mobile app.
Native apps are mobile apps that have been created specifically for a given platform, for example, Apple iOS. Cross-platform apps, on the other hand, as you can guess from their name, are created in such a way they can work across platforms, for example, both Apple iOS and Google Android. Which one is better? Once again, the answer depends on the purpose and type of your mobile application and business in general. Native app advantages: you can utilize all the platform's abilities, including hardware, in your application. For example, seamless integration with Siri or 3D touch technology on iPhones. The app will be more efficient because the features will be optimized for the given platform's abilities. In case you're creating an app that would be a part of an ecosystem, for example, it should work on both iPhones and Apple Watches, a native app is a way to go. Cross-platform app advantages: the code is usually easier to support. Business logic is located in one place, which helps with testing the functionality simpler and more straightforward. You also don't have to rewrite the same business logic several times for each of the platforms. Cross-platform apps are a wonderful solution when you need a web app shell without major integrations with third-party resources.
Okay, so it is about your needing. However, it is usually hard to develop a cross-platform application.
Agile methods and MDA. The developers of MDA claim that it is intended to support an iterative approach to development and so can be used within Agile methods. The notion of extensive upfront modeling contradicts the fundamental ideas in the Agile Manifesto, and I suspect that few Agile developers feel comfortable with model-driven engineering. If transformations can be completely automated and a complete program generated from a PIM, then, in principle, MDA could be used in an Agile development process as no separate coding would be required.
You see, every time it uses the word principle in principle because it is still not possible in actual programming.
Executable UML. The fundamental notion behind model-driven engineering is that completely automated transformation of models to code should be possible. This is possible using a subset of UML2, called executable UML or XUML.
This can have some possibility at the moment, but let's check it out if there is a good example of it.
Features of executable UML. To create an executable subset of UML, the number of model types has therefore been dramatically reduced to these three key types. Domain models that identify the principal concerns in a system. They are defined using UML class diagrams and include objects, attributes and associations. Class models in which classes are defined, along with their attributes and operations. State models in which a state diagram is associated with each class and is used to describe the life cycle of the class. The dynamic behavior of the system may be specified declaratively using the Object Constraint Language (OCL), or may be expressed using UML's action language.
Okay, so the key points of part 2.
Key points. Behavioral models are used to describe the dynamic behavior of an executing system. This behavior can be modeled from the perspective of the data processed by the system, or by the events that stimulate responses from a system. Activity diagrams may be used to model the processing of data, where each activity represents one process step. State diagrams are used to model a system's behavior in response to internal or external events. Model-driven engineering is an approach to software development in which a system is represented as a set of models that can be automatically transformed to executable code.
This looks like more in theory at the moment. I will do a quick recap to show some of the UMLs that we didn't see. Okay, graphical models, context models, system boundaries, context, process perspective, interaction models, case modeling, use case. We have seen that. We have seen use case. We have seen sequence diagram, structural model. Okay, we have seen the class and associations. We have seen classes. Then we have seen generalization hierarchy, aggregation model, aggregation association, behavioral model. Okay, maybe we can find. Oh, we have seen that as well. This is activity model. So this is database. Let's see some examples from behavioral model. Okay. Order processing, event-driven modeling, state machine. Okay, I think we have seen everything. However, for this model-driven architecture, let's try to find some more information about executable UML. I wonder if it is really possible. Okay, there is a page, most complete list of executable UML tools. Okay, so there are some toolkits, and I wonder what are possible with them. So this is called as Cameo Simulation Toolkit, and let's try to find example of it. I will try to find from YouTube.
In this video we will show how simple value plotting.
So it generates output like this. User interface prototyping. Let's see what is the output of this. So this looks like our Windows Forms or VPF in C#. Executable flashlight sample. But they all look pretty simple stuff,
In this video, we will create
not any advanced software. You see there are states here. He is coding. And let's see the output. Okay, so this is the output. I see.
create here, and this is
Actually, this looks like even more complexer than actual programming. Okay, anyway, if you are interested in executable UML or model-driven approach, you can check more about that. However, as far as I know, multi-platform development is a real thing, and it is being used. So you can really check these cross-platform development. So React Native, as you can see, it is number 1 according to this page, Xamarin. So let's see, and okay, create native apps for Android and iOS using React. This is very popular. Written in JavaScript, rendered with native code, many platforms. Okay. So let's check the platforms of React. Since it is JavaScript, it is probably working in many of the platforms. Okay, there is the second one is called as Xamarin. Okay, so you see.
Microsoft Visual Studio Xamarin allows you to build apps for different platforms such as Windows, iOS, and Android using a single .NET code. The best part of the Xamarin cross-platform tool is that all the apps built on it look and feel like native apps, and this appears because it uses the native interfaces that work the same way a user wants to use them. With Xamarin, you can give your app a platform-specific hardware boost to achieve the performance similar to native apps. Also, most of your coding, approximately 75%, will be the same, regardless of the platform you're building your mobile application for. Xamarin works on a single code by identifying it and accelerates the process for cross-platform mobile app development. Xamarin works on both Mac and PC systems and offers you tools such as debugging, UI design tools, and code editing.
Okay, so there is also Flutter. This is also pretty popular.
Flutter is the software development kit (SDK) that allows you to build high-performance applications on various platforms such as iOS, Android, web, and desktop from a single codebase. This open-source UI SDK is created by Google and it was initially released in May 2017. Flutter utilizes Dart programming language. This language is easy to understand for JavaScript or Java developers. It helps most of the object-oriented notions. If you want to develop a custom application for both iOS and Android platforms, then Flutter may be the best cross-platform for you. This platform is utilized for developing very well-known apps that are Google Ads, Alibaba, etc.
Okay, there is also Ionic, Apple Selector, and such. I wonder if there is cross-platform. PC and PlayStation and Xbox. Okay, there are cross-platform games. However, it doesn't explain how they are cross-platform developed. Okay, so they are trying to develop a cross-platform XDK. I see. Okay, let's read this so we can have more idea.
Ultra has announced its cross-platform software development kit (SDK) that is compatible with Steam, PlayStation, and Xbox. The suite of tools has been created to enable game developers on any platform to seamlessly integrate blockchain technology into their projects. Previously, many PC game developers utilized the Steam SDK because it is the most popular platform for computer-based gaming. Ultra is aiming to provide game creators with more flexibility, as its own software development kit has parity with not only Steam, but also Xbox and PlayStation. It will also be compatible with iOS, Android, Linux, macOS, and Nintendo platforms. In doing so, developers on any system will be able to implement blockchain technology and incorporate features such as non-fungible tokens (NFTs) into their projects.
This doesn't look like what I am looking for. However, it is also a class platform. Okay. Okay.
Developing a cross-platform solution is not a simple process. it requires careful consideration of many aspects that are crucially important for successful product development. In particular, you should pay enough attention to choosing proper cross-platform technology at the beginning, since it is nearly impossible to replace it in your architecture in future. Therefore, intended to simplify your decision-making journey, the article provides a brief overview of the most popular cross-platform languages: Java, JavaScript, C++, and C#.
Okay, so you see the platform like below platforms.
Software platforms lets combine software platforms into groups: desktop, Windows, Unix, Mac OS browser, Chrome, Firefox, Safari, Opera, i.e. mobile, Android, iOS, Windows Phone Game Console, PlayStation, Xbox, Nintendo Server, Unix, Windows Server Others, Smart TV, Smartwatch, cameras, etc.
So the most popular cross-platform language is Java. Okay. Okay, and C++, JavaScript. So you see the JavaScript tends to browser, C++, desktop, mobile, game console. You see this is their tendency. JavaScript and C# is mobile, game console, server, desktop. Okay, there are a list of game engines which supports cross-platform, A4 engine and such. Okay, you see the target platforms here. So they are using engines to generate games, and whether they are cross-platform or not, you see many of them are cross-platform at the moment. So you can also check this if you want. Okay, I'm going to end the lecture. We are still looking for subtitle helping. Let's see our current status. Okay, so far everything is in progress or completed, so I will be needed for this lecture. I think it will be easy for you because I have improved my voice quality and also software, I mean subtitle generation, post-processing. Okay, hopefully see you next week. Stay safe, be aware of coronavirus. Okay, end of lecture 5.